Online Class Philippines. Welcome to Science 7 class. Today, we are going to study about elements and compounds. One useful way of organizing our understanding of matter is to think of a Mohs hierarchy that extends down from the most general and complex to the simplest and most fundamental. Matter can be classified into two broad categories: pure substances and mixtures. Look at the hierarchy. We have the matter down to pure substances and mixtures. Pure substances is divided into elements and compounds, while mixtures is divided into homogeneous and heterogeneous. A pure substance is a form of matter that has a constant composition, meaning it's the same everywhere, and properties that are constant throughout the sample, meaning there is only one set of properties such as melting point, color, boiling point, and other more throughout the matter. Elements. A chemical element is a pure substance that consists of one type of atom. Each atom has an atomic number, which represents the number of protons that are in the nucleus of a single atom of that element. The periodic table of elements is ordered by ascending atomic number. The chemical elements are divided into the metals, the metalloids, and the non-metals. Metals, typically found on the left side of the periodic table, are often conductive to electricity, malleable, shiny, sometimes magnetic. Examples: aluminum, iron, copper, gold, mercury, and lead are metals. Look at the table. Metals are the blue. In contrast, non-metals found on the right side of the periodic table to the right of its staircase are typically not conductive, not malleable, dull, not shiny, not magnetic. Example of elemental nonmetals include carbon and oxygen. Look at the table. The nonmetals are the red. Metalloids have the same characteristic of metals and some characteristics of nonmetals. Silicon and arsenic are metalloids. Look at the table. The green boxes are the metalloids. Compounds. Pure samples of isolated elements are uncommon in nature, while the 98 naturally occurring elements have all been identified in mineral samples on the Earth's crust. Only a small minority of them can be found as recognizable, relatively pure minerals. Among the common of such native elements are copper, silver, gold, and sulfur. Carbon is only commonly found in the form of coal, graphite, and diamonds. The noble gases, example neon, and non-metal, example mercury, can also be found in their fewer, non-bonded forms in nature. Still, most of these elements are found in mixtures. When two distinct elements are chemically combined, example, chemical bonds form between their atoms, the result is called a chemical compound. Most elements on Earth bond with other elements to form chemical compounds, such as sodium and chloride, which combine to form table salt or sodium chloride. Water is another example of a chemical compound. The two or more component elements of a compound can be separated through chemical reactions. Chemical compounds have a unique and defined structure, which consists of a fixed ratio of atoms held together in a defined spatial arrangement by chemical compound. Chemical compounds can be, here are the examples. Number 1, water. The formula is H2O. 2 part of hydrogen plus oxygen. Two atoms of the element hydrogen combine with one atom of oxygen through a covalent bond to form water. Water can be spilled back into hydrogen and oxygen through electrolysis. Another, hydrogen peroxide. Formula H2O2. Hydrogen peroxide is formed when two atoms of hydrogen form a bond with two atoms of oxygen that have bonded to each other. Although it has only one more oxygen atom that is present in a molecule of water, its properties are very different. Salts. Formula sodium chloride. In salts, one atom of sodium bonds to one atom of chlorine to produce the resulting ionic compound sodium chloride. Salt is quite easily produced for commercial uses by simply evaporating seawater, although it can be mined from the ground as well. Sodium chloride can be separated into its different atoms through electrolysis. Another example is baking soda. Formula sodium plus hydrogen plus carbon plus oxygen 3. Sodium bicarbonate or baking soda can be produced from the reactions of carbon dioxide with an aqueous solution of sodium hydroxide. It is found naturally in hot springs and other places on Earth, but is commercially produced for industrial uses. Thank you. See you next time.